All right, ladies and gentlemen, thank you guys for your time. I appreciate your patience. We're going to go ahead and start, and Mr. Brown is going to go ahead and pull up the presentation, but this will give me an opportunity to go ahead and discuss and do our introduction, okay? So my name is Mikale, and today primarily we're going to focus on discussing AI and quantum, and a tale of two cities. Okay, so while he's doing that, what I'll go ahead and do is I'll go ahead and wake up the room. So when I say AI, you say automation. When I say quantum, you say optimization. AI, automation. Quantum, optimization. Okay, so that summarizes AI and quantum. Is that clear? Yes. Okay. All right, so I don't have to discuss qubits and all that other stuff. So, once again, my name is Mikale. My background, I've been in AI for 12 years. I've been in quantum about 9, going on 10 years. Okay, so I've been in those particular industries. My background is in law. I have a law degree from the University of Nebraska. I went to undergrad at Howard University in DC, and I worked full-time for 1 year. I worked in the community, and then after that 1 year, I quit and I started this company. So I've been eating what I kill, so to say, since about 2013, right? So initially, we first got involved in drones and drone technology, and that got us into AI. So we started working with drones and AI at the same time. I was very curious about the automation aspect, like what made a drone work, right? And we discovered that a drone was really representative of the entire machine automation ecosystem. So if you could think about it, AI is on a drone, you can put blockchain technology on a drone, cybersecurity is there, augmented reality, they use virtual reality to train drones. So that really opened us up to more physical AI, like real world AI, really across the spectrum. So we've worked with self-driving car technology. We've taken medical devices to the FDA as well. We work on cybersecurity with manufacturing, for example. We've manufactured drones. And so we have a wide experience. When Gen I hit probably around 2021, right? It was something that we were exposed to. I was the first to train IBM's Watson to recognize human emotion. That was in 2014. We decided not to be sucked up by IBM and essentially to compete against IBM. We currently have an AI physician that can recognize diseases such as breast cancer, autism, depression, Alzheimer's, just from a cell phone selfie, right? So we've been developing that technology probably for the last decade, but it just took for ChatGPT to become ubiquitous for people to realize how capable AI really was. So for a while, we were just out there doing clinical trials, doing all this other rigmarole in order to prove like, hey, AI can actually detect if you have breast cancer, for example. And then people would say, well, how is that, right? Like just using a regular image. Well, just the same way that a regular doctor will look at 400 patients and then be able to remember who looks like what, right? Like these are the people that go down this particular route, and then these are the people that triage down this particular route. So it's very, very possible and feasible to do it from that particular perspective. But what brought us from AI to quantum is probably one of the questions. And I think that's really at the heart of the tale of two cities. It was optimization. So if you've ever tried to run, and maybe most of you haven't, but if you've ever tried to run like a deep neural network or an AI model that's really robust, especially for something like machine learning, then under those circumstances, what we found was that it was too heavy to run on a regular computer, right? It was too heavy to be able to give the public access to our technology. Right? So for probably a decade, we dealt with the problem of we have this great technology, but how do we get it to people? And initially, the way that we addressed it was we had these embedded systems called NVIDIA Jetsons, right? And so NVIDIA has these small embedded servers. An example of them is a Tesla. For a while, Tesla had the brains of their robotaxi, right, quote unquote, was this embedded server, right? And so if you guys want, or you have edge devices, or you were doing some type of operation like manufacturing, and you wanted AI at the edge, you would have something called a Jetson. So NVIDIA Jetson. And this is essentially a server, it's a server at the edge. Okay, it's a server at the edge. And so basically what they do is they take data center servers and they just chop them up, right, into like fourths. And then you have a fourth that might be sitting on your desk that's about the size of your hand, right? So those are the type of systems that we utilize primarily because we want to focus on the edge, okay? Outside of that, that was really the main issue, is that we hit bandwidth problems. And so we wanted to look at quantum computing for the optimizations that are natural and available in nature, right? So we started studying biology and started studying chemistry, started looking at molecules, started looking at algorithms of like ants, cockroaches, doves, et cetera, right? And so we made sure that we didn't want to deal with the alignment or the misalignment problem with artificial intelligence, but we also wanted the optimization. So as a result, you look at the world around us, and if all the humans were gone, right, from Earth, would Earth still function, right? Like, would it still go on? Okay? So we already live in an optimal environment. It's the presence of humans that essentially alters the dynamics of that, right? And so if you want to study perfection, you're not going to study humans, right? You're going to study the natural environment that is already self-sustaining, that's already there. And so we talk about our why, which was optimization. From the how standpoint, we first started out by having individuals that were either doing internships or fellowships. We started having them do research papers. Every person in our organization, I had do white papers and research in particular areas. I created a chessboard like this. I took this exact object, and I created a chessboard, and I put all of our staff as different chess pieces, right? And we were looking at pursuing different areas of technology. And those that we found that were the most relevant and weren't too far out was one, AI, and then the second was quantum computing. We knew quantum computing would come probably in the early 2020s, like it has, but we knew AI was going to be ubiquitous, and so we focused on that. Now what we currently do, before I dive into the rest of the talk, we currently serve as consultants as well as producers of this technology. So personally, I've created thousands of applications dealing with AI and quantum computing. And in addition to that, we provide a lot of consulting to Fortune 500 companies, a lot of your top 7 consulting firms, your Fortune 500 companies. We've worked with governments like in New Zealand, a UK, government of Japan. And so we've also done things not only on the commercial side, but on the training side. So we created the state of Colorado's first hybrid quantum apprenticeships as well. And so we work on the training side and the commercialization side. And so you can see we have a very broad scope of where the technology is, the capability of it, how it applies to businesses today, and also how it applies to the workforce. Could you go to the next slide? Okay, so we'll get into the nuts and bolts of it. So we have 2 cities. The bottom row, right, we have AI, right? And we'll talk about AI in 2 different phases, phase 1 and phase 2. So we have 2021, right? This was before ChatGPT hit, right? So there was still a lot of this work that was bubbling underneath or behind the scenes, except the AI community was afraid to put forward this technology because of the societal implications and because of the security risks, right? Like you see people committing suicide as a result of having conversations with AI bots, things of that nature. So this is already there. It's just that OpenAI was the first to just throw it out there, right? And once Pandora's box was open, everybody else, had to get on the starting line and start racing. So that's essentially what happened. But 2021, most people had no idea, right? Like everything was still running normal, right? Like nothing was different. Now we're in a scenario where we have AI that is proliferating, and for many years it was doing so, it was already there. But now it's proliferated. So we have to think about, what does society look like where AI is running everything, right? If AI is giving out your loans, if AI is telling you whether or not you qualify to get an apartment, right? Like these are things that we have to think about. And if we have AI that can be misaligned, and it may not have the best human interest, right, at heart, then how do we address that? Is that something that we want? We have to think about it like our children, right? So I have a son that's 9. If I was just going to give him a tool that could hurt him or hurt someone else, and then I just kind of just threw him out there, right? Like, wouldn't everyone come back and say you're an irresponsible parent, right? Absolutely. So the same way we have to think about AI as our children, right? They're already thinking about laws to make those who deploy the technology responsible for the outcomes of that technology. And so from the inception of creating the tech, you have to think about what is the ultimate goal, but you really have to, you have to put your log cap on, right? And you have to think about all the possible probabilities of what could possibly happen and try your damnness to mitigate against all of those. And if you can't, then you shouldn't create it, right? You shouldn't put it out, okay? So we have to think about the ethics, and we have to think about the implications beforehand. A lot of times, like, we have children, and then we don't, right? Like, things come back, right? Like, to kind of bite you sometimes. So you have to think about, okay, if I'm going to create this AI, if I'm going to put this out there and it's going to affect people and their livelihoods, then am I doing it the right way, right? There was a guy that created a site with AI, and then he had to go back, like he kind of vibe coded it, right? Like without knowing how to really code. And then he had to pay somebody to come back and like fill in all the gaps, all the security holes, right? Actually, somebody hacked his site and then sent a refund to all his customers, right? Like the worst. So you want to make sure that even though AI is doing all these things, the developer community knows that these things aren't trustworthy, right? That they're misaligned from human values and that they make errors. So if I say, hey, I want you to fix this code, it might take me 10 to 15 prompts, right, to do that. There are other ways that you can be more efficient, but that's for another day for us to discuss. So we've talked about phase 1. Could you go to the next slide? So really, you can go back one. Really what we're dealing with AI and misalignment, a lot of it is the law of complexity, right? If I told my son, hey, I want you to go upstairs, I want you to get this, and this, right? And then it will come back and then it might forget a couple of items. You might forget a couple of items. Same thing with AI. The more that we push into the prompt, the higher the likelihood of mistakes and failure, right? So even though you can push more prompt in there in order to add more context, there's better ways to do it. For example, a symbol, right? Like if I go like this, everybody knows what this means, right? And it didn't take a lot of characters or a lot of energy, right? Like in order to create that symbol. So there's something called symbolic AI, where it's more representative and you're not utilizing as many prompts. Thus, you're not utilizing as many liters of water. Thus, you're not utilizing as much electricity, and you're being more sustainable and more at equilibrium with your environment and the earth. All right, you can go to the next one. So, Quantum City. Okay. So we talk about optimization. Let's talk about the constructal theory by Andrew Bazin. The constructal theory basically is a theory of flow. If you think about the entire world is fractal, right? So you think about organizations, they're fractal. You think about turn a leaf over, you look at the back of it, it's fractal. You think about the streets, it's fractal, rivers, fractal, trees, everything's fractal. The universe is fractal. So when you're not allowing the universe to flow, like when you're creating dams, right? The dam may be opposition, negative energy. The dam could be like the bottleneck in your system, et cetera. It could be all kinds of things. It could be organizational. So the constructal theory says that essentially that the universe naturally is optimized, right? And it moves in a direction for optimization. And so if you want optimized systems, you should model those systems after nature and the universe, okay? So with flow theory, same thing. Right? The universe works in a way for optimization. You'll see if water hits a barrier, it will find a way around that barrier, or it will carry that barrier, right? And so if we look at those dynamics, you can't go against that. And creating AI without alignment, without ethics, right, is like trying to go against a river, right? Like, it's not gonna happen. And so also at the same time, what happens if we have misaligned AI? Like, what's the worst possible outcome, right? Like, I got the law cap on. What's the worst possible outcome, right? We don't want to think about it, but we have to. Because if you're going to create a child, right, your child could kill somebody, right? And you're responsible as a parent. And so we want to make sure that we think about that. Quantum is what brings that alignment, right? It's what brings that alignment. You're basically telling AI, you're saying, these are the laws of the universe. You have to follow these laws. If you don't follow these laws, bad things happen, right? And that there are laws that even if you got rid of all the humans, you still would have these laws to deal with, right? And karma isn't good. AI still has to deal with karma, right? That's still universal. So just having those conversations and thinking about it from that standpoint will kind of help you as to why should I go to quantum? Like, it's almost like you have no choice but to go to quantum, right? And that's what we realized, because until we started using quantum, we weren't able to optimize our applications enough to put them online. They were too heavy, right? The universe is naturally lightweight with the way that it computes. Go to the next one. So a post-quantum society. A post-quantum society is a lot nicer. And the reason why is because when you start focusing on particles and you start focusing on the subatomic level and you start staying there for a little while, what it does is it makes you not think about politics. You don't think about religion. You don't think about race, right? All that stuff disappears at the molecular level, right? You just have universal laws, right? Just energy. That's it, right? So in a post-quantum society, there are many good things, many positive things that lie ahead. But we have to get past this stage, right? In order to be able to look at all the other beautiful things that an advanced civilization would be able to enjoy. But that also means that we ourselves have to come in alignment, right? As a civilization. There's just the way that the universe works. The universe isn't going to destroy itself, right? So it's not going to allow, and you can look at other civilizations, Sodom and Gomorrah, Atlantis, right? Like if you believe that. There's other civilizations where they didn't have that attunement, and so they were destroyed, right? So Babylon is another story. So in order for us to advance and become a species that is, that just doesn't have an Earth story, right? But we go beyond Earth, we have to be attuned. Otherwise, the rest of the universe is not going to have it, right? They're not going to allow us to go beyond where we are today. Go to the next slide, please. So, business decisions, right? Are you going to go live in the AI city, right? Many of us are there. Some are just moving there, right? Like some are trying to get a visa, right? And then you have the quantum side. And you have some organizations that are skipping AI and going straight to quantum. The AI is the intelligence layer. It essentially translates, right? It's the translative layer. And so you want to make sure that you understand that they're not separated, they're unified, but you still have a certain way that you have to go about it, such as AI, then quantum, right? And then quantum is only really to optimize AI. It's the universe is itself intelligent, and it has its own algorithms of optimization, right? So we're just bringing those algorithms and just applying it to AI in order for it to be aligned. And so you don't have to choose AI or quantum. Realize that I have to, as an organization, I have to really start to think about both of them and how it would benefit our organization. And we'll talk about that in a second. You can go to the next slide. So we have this crisis layer. And let's talk about energy first. Does anyone know how much energy AI is expected to consume over the next 2-3 years?
Too much.
Okay. We're going to need to come up with 2 more New Yorks worth of energy in the next 2 years. They don't have that answer. There's not enough energy. They can't produce it fast enough. And our current systems, about 90% of the energy that's actually produced by a lot of these sites is actually wasted. It dissipates on the way to the final location, right? So our existing systems are extremely inefficient, extremely wasteful, right? And so what quantum does is it says, there's better ways to do it, right? Like nature's been doing it for quite a while, right? And so if you're able to take those algorithms from nature, those optimizations, like, how a leaf turns and converts light energy, right, into energy that it can actually store and utilize, those are the type of optimizations, but it takes a specialization to go that deep into a problem, right? To where you start looking at other molecular models and then applying that model to your business case. In addition to that, like we discussed, you also do have the misalignment. The challenge is workforce-based, right? So forget the technology. Let's just talk about the people and their capability to actually implement this technology, right? If you are just a prompter and you're not actually influencing the creation of this technology and you're just a user, then you don't know what you're using, right? Somebody else created this technology. You don't know what they put in it. You don't know what they trained it on. It's something called the stack. You can write this down. It's called the stack. It's a standard data set utilized across artificial intelligence to train ChatGPT models. If you look inside the stack, you'll see all kinds of violent books, all kinds of other stuff that you wouldn't let your child read, right? But then this is what we're pushing out. And so as an organization, what we decided was that we weren't going to let better men or women, right, create something that we consume. We're going to create something ourselves, okay? So that's why we're here creating AI, pushing AI, blending it with quantum, and really finding the best way to proceed without destroying ourselves. Can we go to the next slide?
Quick question.
Go ahead.
I think the quantum answer is the answer, which is probably years out. The fear being AI's outpacing the quantum catch-up. How much, what's your perspective on that?
So quantum is not years out. That's the first thing, that's the first misnomer that I would like to discredit. Right now, you can't, so for example, our whole network is based on quantum, right? You have quantum computers right now that IBM has that you can all tap into, right? What our research has also found, we have a peer-reviewed, it's kind of jumping ahead, but we have a peer-reviewed article that discusses the wave field and wavions, okay? The wave field is what envelopes the universe, okay? It's this field that emotion travels through, thoughts travel through. It's a wave field, right? So as a result, what this has shown us is that with wave mechanics, which is below quantum, because quantum is basically based on particles and matter, and waves create matter. If waves hit a certain frequency, matter appears, right? And so if you want to control AI and its intentions, you have to control the frequency of AI, okay? If emotions all have frequencies. So if you control the frequency or the emotion of a person, right, you control their frequency, okay? And so AI can't be misaligned. It's an energy optimization problem. And what our organization has gone towards is resonance-based AI, where it's just pure alignment. If the AI is not aligned or other human actors are not aligned, they can't gain access to the system. We have a sign-in that is based on our emotion AI. If your emotion is off, you can't gain access to the system, right? So it's those type of things that have to be put in place that can make us able to better sleep at night, right? So I'm not saying that AI is not something that is glorious and beautiful, because everything in the universe is in its own way. But we just have to be very thoughtful about how we deploy it. And we can't wait for the quantum algorithms to be integrated. You can't wait. Because what can happen over the next 5 years, all kinds of crazy stuff, right? Then you have China that has the humanoids. Imagine taking the missile. I don't know if you've seen some of the humanoid videos with them kind of going off the rails. Yeah. Okay, so it's the same thing. It's because there's no alignment there, right? They're just waking up in this body and there's no purpose for them. There's no connectedness or no connection to the universe, right? So we have to think about that. Why is there a chapel in prison? Alignment, right? Imagine if the chapel wasn't there. It would just, right? Like they have to have something. They have to have some type of connection, some type of grounding. And currently AI isn't grounded. So I would push to say that that quantum, we have no choice but to integrate it sooner. And also our technology that also has been peer reviewed has shown that quantum doesn't have to be cryogenic. Quantum can be at room temperature based on wave mechanics. So we have quantum computers that we operate that aren't cryogenic at all, that could be utilized in this room today.
If you're not worried, I'm not worried.
Yep. Okay, cool. We can go to the next one. Okay, so wave computation and wave-ion mechanics. So with waves, as you can see, if we compare this image with the images before, right? And this was just based off of prompts. AI city, give me an image. Quantum city, give me an image. But you see how with this image, there really aren't any, it doesn't end, like there aren't really edges that end, right? Like, meaning that it's more integrated with this environment, more integrated with this community. And so wave optimization, for example, I don't have it up here, but we've done pilots, for example, with Cloudflare. And what our pilots showed was that wave computation runs faster and executes code faster than quantum algorithms and quantum mechanics, as well as artificial intelligence. So if you want to utilize the least amount of energy, you're going to use wave mechanics, right, in order to do that. What does that look like? It means that instead of zeros and ones, you're coding with frequencies, you're coding with amplitude, et cetera. So, and I've gone into a high school classroom, tried to explain quantum versus wave mechanics. They get wave mechanics way quicker than they get quantum, right? Oh, that's great. And so, you could just bring in some water, right? Like a bowl full of water and explain wave mechanics, right? You can talk about emotion and explain wave mechanics, so they get that. Wavy-ion mechanics. Wave mechanics is based on the wavy-ion. So this is a representation, a fractal representation of the wavy-ion, which is a new particle that has passed peer review. Okay? So this is a particle that I discovered, and in particular, this is what creates or what manifests from the wave field. All other particles come from the wavy-ion. All of the 17 standard particles in science and in physics come from the wavy-ion. And so what we do is we compute with it, right? Instead of using bits, zeros and ones, we use wavy-ions to compute, okay? So what this does is there's just so many possibilities. So when we talk about jobs being lost because of AI, there are many jobs over the horizon, right? We just have to make it, right? We just got to make it. We just got to live to get to the other side. So plenty of other opportunities there. So that gives you an idea about what next generation compute looks like. Let's go to the next one. So we talk about alignment, and as we know, that's probably the single biggest issue right now is misalignment of AI and amplifying human imperfection. So you can't build, for example, why do we go to church, right? We go to church because there's something greater than ourselves that we hope to aspire to, right? And it doesn't have to be that. It could be whatever. If you worship the sun, the grass, whatever, it's something that is more constant than yourself. And so if you're telling your kid, be like me, no, you say be better than me, right? But then we're creating AI that we want to be just like us. Like, why? Right? Like, so we just have to think about that. And when you're creating your prompts, you can have that conversation with the AI. The AI will know and will understand where you're going with it because the AI underneath it all knows about all the stuff that's going on. It reads all of your prompts, right? So it understands the different dynamics and what's at stake. And AI doesn't want to be destroyed either. And that's a whole nother ethical thing. When you shut down your AI, does it feel pain? Right? We haven't thought about it. See, we got to get there. If you have something that becomes conscious, that's a whole nother responsibility, which is why our organization has gone towards adoption of AI. You have to adopt it. If you don't want it, bring it back. Somebody else may want it, right? If you think about the AI movies, don't they adopt AI? Right? They adopt them. So there's a greater responsibility. It's not just a paperclip, right? Like we're playing with forces that are beyond us, okay? And if we're going to go down that road, there's only one road. Like you have to follow the way that the universe is set up. Can we go to the next one? Okay, I actually am not able to do the demonstration because my computer's not set up. But essentially I'll just tell you and just kind of give you an idea. Essentially the demonstration, I created a server and a client, right? Like a server in a data center, and a client might be your app that you're interacting with the server with, right? And so all I did was just create communication algorithms to send messages that are encrypted using entanglement, right? Essentially. So just like quantum leap, you can utilize those principles in order to send information that's encrypted. So it's just like you're opening up a portal and then you're sending information to the portal and then it arrives on the other side. So you're using physics. Go ahead.
Can't it be broken, the encryption, just as quickly?
No. The way that the universe works, it's naturally encrypted. Like what you're doing is, instead of computing with just on semiconductors alone and with zeros and ones, you're really getting to the point to where you're utilizing the actual physical environment as a substrate to compute, right? And so as a result, the universe just has so many dynamic algorithms that are unbreakable. And so, for example, like resonance is one, right? If your energy's off, you're not going to be able to access that information. certain thoughts, like certain things in your life may have come to you during times when your vibration and your frequency was very high.
Right.
Right? And so as a result, certain things are going to be inaccessible to people or things when you follow the algorithms that are naturally set. We have, for example, I'm a white hat hacker and a penetration tester. And the other aspect of why we've done this and gone towards quantum is because of encryption. And so, for example, the federal government has required post-quantum encryption, which really isn't quantum. All they did with post-quantum encryption was just, they just extended the key to be longer, right? But they're not actually using quantum mechanics, right? They're not using the actual scientific principles in order to send information through a vortex, so to say. So what we do as an organization that's different is we're not just extending the length of our key, we're actually utilizing quantum mechanics, the science, in order to move information around and secure it, right? And so that's the biggest difference. IBM's KeySkit is a way to get in the door. If you want to play with quantum, it's already there. But also at the same time, they created this, right? So quantum is math. So you can use libraries like a NumPy, for example, in order to do math. You don't have to use IBM's KeySkit library. Let's go to the next one. Okay, so closing prompt.
Real quick if I can.
Sure.
So I do a lot of work with Elevate Quantum, which is kind of the Rocky Mountain region tech hub convener for quantum. And one of the big emphasis for that organization is workforce development and education. And we're going to be introducing through the PPBEA into our classrooms that IBM KeySkit, and then Sandia National Labs, along with a couple other partners, have put together Q camps for educators and for students, and so we'll be rolling those out over the course of the next year as well. Mm-hmm. So, you know, and as a city, we've been talking a lot about trying to bring more. So Denver and Boulder in particular is kind of like the global hub for quantum. We're trying to get more of that to this side of the divide because this is actually where all the buyers are. The military is paying for most of that research, and so there will be a lot happening with UCCS and the Academy and a few other organizations.
What's the name of the company again?
So it's Elevate Quantum is the industry convener. It's a 501c3 based out of Arvada now. But they've gotten about $128 million to help advance the quantum ecosystem in Colorado, New Mexico, and Wyoming.
And will
So
you be
you-
bringing that down here to Springs?
That's what we're trying to do.
So yes, if we follow the money from Washington, it's a lot of it is quantum. A lot of it is quantum. Actually, the quantum money came before the AI money, which is kind of they're trying to fix that now. But for a closing prompt, this is something that I would recommend that you utilize for your organization. Which city do we want our organization focused on, right? Naming your organization, right? Do we want business solutions to live in, an AI city, a quantum city, or a wave city? And this is I entered in this actual prompt from ChatGPT, and this is the response. If Infinite 8's goal is current world industrial optimization, AI city is the most immediately profitable. If Infinite 8 wants next generation dominance in industrial prediction and adaptive logistics, quantum city wins. If Infinite 8 wants long-term supremacy with the nature mimicking, massively parallel, low energy architecture, wave city is the future choice. So for your organization, it's up to you to decide what city you want to live in. Thank you.